We're going to start our unit on systems. So you can start by graphing these two lines and see in fact where they intersect, because that is what systems are going to describe. Do pay attention to the scale when you do this. There is joules in red. I'm going to do Astrid in blue. Notice that this is 25 over 1, so that is the same as 50 over 2, so that when we're looking at finding those nice pretty points, and we can see in fact they intersect at 6 and 200. So what does that mean? Well, that means we need to look at our units. So the 6 is our X, which is weeks. The Y is 200, so that is money. So in order to prove that that is in fact the answer, we would simply need to plug those numbers in for the X and Y into each equation. So in joules, 200 equals negative 50 times X plus 500. When we put that into the calculator, we get true. And for Astrid, 200 equals 25 times 6 plus 50, which is also true in the calculator. A system of equations is two or more linear equations that use the same variables, same variable forms of a system of equations, and it is the solution is a coordinate point. That makes the equations, both of the equations, true. That's always a big deal. It has to be true. When a system of linear equations is graphed, we can find the solution by looking at the point of intersection. This is just one way to find that we're going to start off with. We will, as we continue the unit, we will look at other ways as well. So if we're going to graph these, which we are all very good at, do pay attention to the slope. It is negative. And you will want to draw those lines super carefully so that you can find that point of intersection. Now, rise 1, run 2, we only have so much space there. So remember, we can go down and left. Our point of intersection here is negative 6, positive 4, and again, you can plug that into your calculator to check your work. On number 2, remember we talked about this is an OI. Horizontal line is y equals. So when we graph the second one, we're at negative 3, going down to an over 1. There, in fact, is our solution, 1, negative 5, because we're just looking for that intersection. Here we have more of the same. I'm going to let you try those. I will give you the solution so you can check your work. Negative 1, 0, and this one is 6, 7. So I would like you to attempt that. Remember, this is a Vux, this X equals. We do have a word problem down here that's describing Pedro and Sam. Keywords, when we look at this, per means multiply, so you can see that is in fact the slope. And then again, per, here is our slope. So it says graph the system. So I'm going to go ahead and use red for Pedro. And again, we need to pay attention to the scale. This is saying negative 1/2 x. So I'm going to go down 1 and over 2 for that slope. And then for Sam, he's starting at the origin and 3/4, so up 3 and over 4, up 3 and over 4. So our coordinate is 8, 6. We'll always write our solution as a coordinate, but what does it mean? So now if it's a word problem, we have 8 minutes and then they are both at 6 miles from Sam's house. So now we're going to write the system. So this is just mx plus b. So this first one, our b is 90. Our slope, pay attention to the scale, is down 10 over 2. Negative 10 over 2 is a negative 5. So y equals negative 5x plus 90. And then this bottom one, our b is 10. This one is going up 10 and over 2. So that slope is going to be a positive 5. 5x plus 10. And our solution, oh, I wrote that in the wrong spot. Let me get rid of that. Sorry about that. Positive 5x plus 10, and then our solution here, 8 and 50. And if we had units, we could put that, but we don't. If you want to try to create this, you can. I'm not super worried about this one. And that is our intro to systems.